All right, so we need to continue looking at what this paper and what you really need to have, what you need to prepare as far as your June exam is concerned. So this is just a raw paper, a raw video. That's usually how I keep on making my videos. So I started by putting on here for you the formulas that you require. One of the formula is energy or electrical energy, and remember this formula is very important, especially you did it when you were doing mains electricity. Under waves we talked about the relationship between frequency, time period, work done. Remember, work is the rate of doing work, huh? Power is a rate of doing work. So if the machine is powerful, it will work, it will take a short period of time to do a given period work. We can also talk about power as energy transfer, the rate of transferring energy. You can be able to use this formula. So anytime you're given a question, need to be able to, you need to know how you can be able to use these kind of formulas. And this is motion in the universe. And maybe if we are talking about how celestial bodies move around um, a star or a sun, we have the sun at the center. And if we are talking about a planet that is orbiting around the sun, and at the same time, we can be able to work out now the orbital speed. You need to know the time it takes this object to go around once. Huh? Need also to be aware of this speed equations. Final speed equals to initial speed um, plus 2 times acceleration. But something I need to mention also is that you must know the whenever you are using this kind of formulas, you must write them in SI units. This one is also a very important formula when it comes to pressure. And maybe you know pressure 1 and pressure 2, you know volume 2, but you don't know the pressure 2, so you can be able to calculate that. So all these formulas are quite important and given to you. So anytime you are given a question that requires you to use a formula, the most important thing you need to do is to highlight what you are provided, and then you can be able to check what you are missing. Another question I've tried to work out is area concerning motion graphs. This is a distance time graph. Yes, you can see now at this given point, we are given distance on the vertical axis and we have time in minutes in the x-axis. So which means we are supposed to state the formula of average speed. The formula for average speed in this case actually is given by total distance moved or total distance covered over the time taken. So for us to calculate the average speed for the airplane during this part of the journey, we're going to use the total distance, which is 700 kilometers, divided by 60 minutes, but this is equivalent to 1 hour, so that I can be able to get my speed in kilometer per hour. All right. So during the flight, we are told during the flight, the height of the airplane decreases as the height of the plane increases, and the temperature outside the airplane increases. Explain how air pressure outside the plane increases. Remember, when temperature increases, this increases the kinetic energy of the molecules, making them to vibrate faster, and this makes them to collide with the outer surface of the plane with more force, or quite often. The molecules will collide with the walls of the plane quite more often, and this results to a larger force, which results to an increase in pressure. And if you are new to Proflan YouTube channel, consider subscribing so that in time we are going to upload further tutorials, you'll be notified. We may take this opportunity to wish you the best of luck in your coming exam. And if you're finding value of this, you can be able to share this video to your friends so that they can be able to benefit as well. Right. Give some situations and some energy stores. Draw one straight line from each of the situation to the energy store that it decreases for that situation. Find one. First one, the first one has been done. So, all right, so you can see, and that is exactly what we are supposed to do. Energy is transferred when a filament lamp is connected to the battery. Which method of energy transfer takes place between the battery and the lamp? That is electrical energy. Which method of energy transfer takes place between the lamp and the surrounding, of course? That is light radiation. Right. So question number 3, we are talking about a photograph that shows International Space Station ISS in orbit around the Earth. That is a satellite that orbit around the Earth and usually orbit um, in such a way that is going around the Earth. Which force that keeps in moving around the Earth? That is gravitational force. Which of these also orbit the Earth? So some questions to do with motion in the universe. You need also to know the difference between different orbits. We have orbit of a comet, we have orbit of a planet, we have the orbit of the moon. So, but in this question, we are told to state which one also orbit the Earth, and that is actually um, the moon. The moon is the one that orbits the Earth. A satellite orbits the Earth. A planet orbits a star, that is the sun, and comets orbit the star or the sun. Which of these forces causes ISS to orbit the Earth? This is actually gravitational force. So basically, that is what we've had from the beginning. And then we're supposed now to go ahead to work out the next question. Yeah, if there's any concern you have, you can be able to, you can drop a message, you can be able to leave a comment down below so that I can be able to know whether you are really benefiting from this. All right, once this video is done, it will be uploaded to the channel so that you can be able to follow through. And this time I'm actually doing the working, I'm doing the background working on this video as we are discussing in this live. ISS completes one orbit in a time period of 93 minutes. The orbital radius of ISS is actually 6.8 times 10 raised power 3 kilometers. Calculate the orbital speed. Remember, we had said that orbital speed is actually 2 pi r. Let me just take you straight to where this formula is. As I mentioned in the formula sheet, we have that formula here. 2 pi times the orbital radius. Yeah, so this is 2 pi times the orbital radius, and time period is the time it takes to go around the orbit. So that we can be able to get the answer to that. Let us just go straight to the question. Okay, times the radius, and this radius we are talking about is the orbital radius over the time period. Now in this case, um, we are going to get our speed in kilometer per second, so meaning that the distance should be in kilometers, and this is going to be 2 pi times the radius, which is 6.8 times 10 power 3, divide by time. Time is in minutes, so meaning we are going to multiply this by 60 so that we convert it to seconds. So this is 93 times 60. And if you work out this, let's see what our calculator gives us. 93 times 60, 60 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 times If you work it out, you are gonna get that is 77 rather, 7.66 kilometer per second. Show that ISS completes approximately 15 orbits in each day. So 15 orbits are so meaning that in each day this is going to be number of orbits is equals to total time divided by time for one orbit. And in that case, we are going to have total time is actually 24 hours times 60 so that we get our time in minutes. And this is going to divide by 93. So let's see what we are going to get. Approximately 15, because it's actually 15.48, which is approximately 15 orbits. Question number 4 is about electricity, meaning that as you are preparing for your exams, you need to prepare to answer question to do with electricity, and which quantity is defined as the rate of flow of charge. Which quantity is defined as the rate of flow of charge? Leave a comment below. Which rate of energy is that? Which rate of flow of which quantity is defined as the rate of flow of charge? Okay. Yeah. So what the answer? What do you think? This is correct, right? Correct. So the best option for that case is actually A. Okay. Which quantity is defined as the energy transferred per unit charge passed? And that is D, which is voltage. Power is the rate of doing work, rate of doing work, or transfer of energy. Is the rate of transferring energy. All right. Next question that we have here is a question to do with circuits. So probably you'll have a question to do with that. And here we are told the diagram shows an electric circuit with two resistors, R and S. The current that is flowing through here is 0.6 amperes. Here the current that is flowing is 0.4 amperes. definitely the current that is going to flow down here is going to be 0.20 amperes, because this current is going to split from this, and this current is going to join here, and this one now, the current that is going to move in this direction to this point is 0.60 amperes. So something else that you need to remember, that the voltage drop here is actually the same, but the current is going to be different. All right, now let's see the question that we were asked down here. On the diagram 1, draw the voltmeter to measure the voltage of resistor S. How can we connect a voltmeter which can be able to be used to measure the voltage of a resistor S? So resistor S is this guy that we have at this point. So we want to measure the voltage of this resistor. We are going to connect a resistor such a way that it's actually parallel to the component. That is what we said and what we learned when we talked about connecting resistors. Now, something that you need to remember is that a voltmeter is connected that way because it's a high resistance device. So it has to be connected in parallel like that. All right. What else? Question that asked current measured in ammeter 1. Already we answered that, even though we didn't know whether that question is to be asked. So we are going to say that's going to be what? That is 0.20 amperes. Current in ammeter 2, this one here, this is going to be 0.0. Oh, no way, no way. That's an international crisis. So we need to write that is 0.60 amperes. Because that current joins up, we say that current joins up so that it becomes the current that was at this point. All right, so the next question, calculate the voltage across resistor R. Calculate the voltage across resistor R. So something that you need to remember is that voltage is connected by the equation that connects voltage, current, and the resistance is V is equals to current times resistance. So which means for us to work out the voltage at R, we need to know the resistance, yeah, and we need to know the current that is at that given point, right? So meaning that since the resistance is 11 and the current that goes that side, let me just say this 0.4 times 11, which is going to translate to 4.4 volts. So this is 4.4, you know. Hmm. All right, the next question states, explain how the voltage across resistor R compares with the voltage across the battery. States how the voltage across resistor R compares with the voltage across the battery. So we're going to realize that voltage across resistor R is actually the same as the voltage across the battery, and we're going to say this because the battery and the resistor R are connected in parallel. So, and you can see there is no any other resistive device. So let us just put it down so that we can be able to understand it better. We're going to say the voltage across resistor R is same as voltage across the battery. And we're going to say this is because both of them are connected in parallel, because both are in parallel, and there is no any other resistive device, and there is no other resistive device in the circuit. In the loop of the battery and the resistor and the resistor R. Yeah, let me just put it more clear. All right, let's check which other question that is down here. Still, we are under the same concept of electricity. Here we are told, explain how the thermistor can be used to vary the current in this circuit. A thermistor, remember, is a type of resistor, a variable resistor whose resistance depend on the temperature. So resistance of a thermistor vary with temperature. Okay, so that is something that you really need to understand. Varies with temperature. So when temperature changes, For instance, when temperature increases, resistance is going to decrease, therefore current increases. Hello? All right, so we have another gentleman here who's walking in the desert. The diagram shows the camel and the person in the desert. The diag describe a method you will use a person exert on the ground when standing in 2 feet. So remember, you'll be given questions like this whereby you are expected to describe an experiment. So some of so we can say, how can we be able to find the area of the feet? 1 foot, eh? Yes. So This is we're going to do that by drawing an outline of the man's foot on the paper. Yeah, so if this is the man's foot, we are going to take a piece of paper and draw the outline of this foot. And then we're going to count the number to say at this part. All right, so to find the area, next we're going to measure the man's weight using a spring balance. Once you've done that, to find pressure, use the formula pressure equals to force over area. And the area we are talking about is the area of the 2 feet. That's the formula we're going to use in order to work out the pressure of this man. The total area of contact of the camel's feet with the ground is 1,300 centimeters square. The mass of the camel is 660 kg. Calculate the pressure this camel exerts on the ground. So we need to know the force exerted, and force exerted is equal to the weight. And remember that weight is obtained by mass times gravity. So you have to remember that, which is going to be equal to 660 times 10, which is going to be 6,600 newtons. Now, since we have the area, now we can be able to apply the formula for pressure. And in this case, we're going to say now pressure is equals to force over area, which is actually 6,600 newtons, divided by the area in contact was given here, which is actually 13 centimeters square. So if what do we get? Which is approximately 5.08. 5.08 Newton per centimeter square. So that is what you are supposed to do, given that question there. Here we are talking about electromagnetic induction. Also is another area that you really need to know how to answer questions from there. A downward force. So which means that this wire